As a math teacher, I get the question from you guys all the time. Miss Cologne, when will we ever use this in our everyday lives? Well, I got some help from some friends to explain to you how they use math in their everyday lives. Okay, everyday math. The regular price of the mouthwash is $3.49. With the Kroger card, you get it for $2.99. But if I buy 5 or more, I get it for $1.99. Am I saving money by buying 5? Or is it a better deal to just buy the one at $2.99?
I hated math growing up, but I learned that it will always be a part of your everyday life. So this is one way that I use math every day on my job. I have team members in different time zones. When I have to schedule a meeting on their calendar, I have to either add or subtract the time because sometimes they're an hour ahead of me or maybe 2 hours behind depending on which side of the country they're on. So on my calendar, it shows that I have a meeting at lunchtime. But for my team member, it's actually 1 p.m. for them. So that's one way that I use math every day at work.
Okay, so we are in Kroger, and these paper towels are $9.99 for a mega pack, which is 18 rolls. How much would that be for one roll?
Yes, ma'am. Yes, ma'am. Right now you have $31,312.49 in the program. Presently, you are paying $309.28 a month. Yes, ma'am. In order for you to add the other 3 creditors, they are like $2,666 a piece. That means that you're adding $8,000 to the program. Yes, ma'am, it is simple for you to figure out what you will be paying monthly. You would take that $31,312 that you already have into the program, and then you would add what you want in the program, the debt that you want added in the program, that $8,000. Once you add the $31,312 and the $8,000 into the program, you have to take 80% of that total. And the 80% of that total, you would take how long you're in the program, which is for 48 months. And you would take that 48 and divide it into that 80%. And that's how you know what you will be paying monthly. Yes, ma'am.
I'm at the gas station, and my car takes 17 gallons of gas. We see regular unleaded is $2.55. The mid-grade is $2.80. And the premium is $3.09. How much would I pay for gas if I got regular unleaded? How much would I pay if I filled up with mid-grade? How much would I pay if I filled up with premium?
I called a professional lawn service in February, and I told them I wanted them to treat my lawn. They said they would give 9 treatments in a year. They came out in March 11th, and they put the first treatment on. But by April, the 1st of May, they hadn't showed up again. So I went and bought lawn treatment for my lawn. Now, did I jump the gun, or were they too late? Did they not do what they said they were going to do? They were supposed to do it on a scheduled time period. And I'm not sure. Did I jump the gun, or were they late?
This is the way that I used math today. So I was driving to school today, and I saw that my gauge was low on my gas tank. So I had to identify how many gallons I had left and how many miles I had left to drive to school today without going and stopping at the gas station. So now I have enough just to get to the gas station today because I calculated that in advance.
And we are looking at Snapple. Snapple is buy one, get one free. If you buy one, it's $5.99. It's buy one, get one free. How much would each one, you're gonna get 2. How much would each one cost? if one was not free?
As a nursing director, this is how I use math at work. All of my nursing positions are listed here. There are 76 nurses, but some of them are part-time and full-time. They're color-coded. So I have to figure out how many full-time equivalent positions do I have. So I need to take their positions and calculate those who are 6 hours per schedule are 0.15. Those who are 12 hours are a 0.3, 18 hours are 0.45, 24 hours are 0.6, and then 36 hours are 0.9. I calculate all of those, and my total full-time equivalent is 58.5, although I have 76 total nurses. They don't all work full-time. That's how I use math at work.
This is my friend Jaden, and he wants to tell you what's that number on his shirt. Jaden, what's that number on your shirt?
1.0.
Good job.
There you have it, and that's how we use math every day.
Hello, my name is Mr. Gorney. I'm a 5th grade science and social studies teacher. And today we're going to show you how we can blow up a balloon without using air from our mouth. The ingredients you'll need for this are some vinegar, some baking soda, an empty water bottle, a funnel, and of course a balloon. First thing you're going to want to do is make sure your water bottle is empty, and then take your vinegar and pour about 1/4 of the way to maybe 1/3 of the way full of vinegar. And I'll be doing that here. And we want to be careful, make sure we don't spill any. And about there. Let's see if I can show you, there we go, so you get an idea there. Put the lid back on the vinegar. Next thing we're going to do is take our balloon and we're going to put it on the end of the funnel. And you want to hold this part here because we're going to pour baking soda into the funnel so it'll go into the balloon. Now, you want to make sure your baking soda is nice and powdery. If there's chunks in there, you're going to want to take a spoon and break it up so it's nice and smooth and it'll go through the funnel. You want to fill your balloon about halfway, 3/4 of the way. So I got that in there, and I'm going to just tap on that. I got that big chunk there, so I'm going to break that up. And keep tapping away till the baking soda goes into the balloon. Okay, good so far. I'm going to take the balloon off. And this is where you're going to probably need help with, have a family member maybe help you. You're going to take the balloon and you're going to stretch it out, the opening, and just put the opening over the water bottle, just like that. So we have our setup like this. Our baking powder is in here. And now I want you to make a prediction. What do you think will happen when we put the baking soda into the water bottle with the vinegar? Take a moment and think about that. And we'll go ahead and do that. Go ahead and hold your water bottle, and you're going to lift the baking soda into the water bottle, and there is our magic balloon. And you can see if you feel any temperature on the balloon. You might want to hold on to the balloon so it doesn't blow off. See, it's inflating, 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 inflating. And we have a magic balloon inflated. Pretty cool, huh? Science rules. Hope you enjoy, have fun, and we will see you in the future.
Hey boys and girls, it's Miss McNally coming to you live from the McNally kitchen with taping done by Mr. McNally. So what do I have here? I've got a glass, I've got some honey, I used my handy dandy turkey baster to measure out a volume of 1 ounce of honey. I got it started so you wouldn't have to stay here all night watching me do this. What I'm going to do is I'm going to put different layers in the cup, and they should stack. They have different physical properties. The next thing I'm going to do is put in my layer of syrup. Remember, I'm getting a volume of 1 ounce. So in it goes to fill that up. Whoops, come on, syrup. I've got my little markings there. Almost, not quite. It's 3/4 of an ounce. So if I put a little more than 1/4 of an ounce this next time, I'll have about 1 ounce. The important part for this now to put the liquid in is to hold it over the center and to put it in slowly. If you put it in too quickly, it's going to take this a long time to settle. So I'm drizzling it in, and I'm drizzling it from the center. Trying not to have too much force. There we go. It's a pretty thick liquid, so it's already wanting to come out kind of slowly. But if I gush it out and it goes in with a lot of force, it's going to mix, and it'll take a while to come out and separate. About another 1/4 of an ounce should get me to 1 ounce, because I had 3/4 to start with. So here we go. It helps if your bottle isn't so low to start with. But with teenagers in the house, oh my goodness, things don't last. So remember, I had almost 3/4 of an ounce last time. So I want just over 1/4 of an ounce this time. That'll get me close to 1 ounce, about 1 ounce, an estimate. So here I go with the rest of my syrup over the middle and going in slowly without a lot of force. Can you see down there that I have 2 different colors? I have a nice golden color honey, and then I have the brown color just stacked on top of it, floating on top. It's buoyant on top of the honey because pancake syrup is less dense than honey. Hey boys and girls, so we're ready to do our next layer, and just a little reminder that you need to do this in your kitchen like I'm doing in my kitchen. Don't do it on mommy's carpet or her brand new living room sofa, because that's too hard to throw in the washing machine. I can throw this old placemat in the washing machine. Okay, my next layer that I'm going to use is Dawn dishwashing liquid. I like to use liquids that are different colors in my density tower because it just makes it look neato. And it's obvious that different things are floating on top of each other. So here I come with my Dawn liquid. Got 1 ounce. And again, I'm not going to use a lot of force because then it'll want to mix and it'll take it a while to settle out. So I put it in slowly. I try to have it in the center, away from the sides. Wanting it to go in just a drizzle. I'm not going to force it in because then I'll be here 3 hours waiting for my liquids to settle back out and float. But if I put it in slowly, they ought to float pretty quickly and settle out because of their different densities. Remember, I have the same volume. It takes up the same amount of space in my turkey baster each type of liquid. Must have been some water left over in that turkey baster from when I cleaned it last time. I've got some bubbles going on. Okay. Let's cut. Okay, boys and girls, now we're on to the most interesting layer for me, because normally I have milk when I do this, regular cow's milk, and it would go down below my Dawn. But because my son is home from college and he likes almond milk, that's the kind I have in my fridge. So it's actually less dense than cow's milk. So much so that instead of being lower than my dishwashing liquid in my density tower, it's higher. Almond milk floats on top of dishwashing liquid because it is less dense. Here's my ounce of almond milk. So I'm slowly drizzling that onto my density tower. And it's going to, sorry, my little hand's in the way. My husband's tapping me. Get your hand out of the way. It's going to float on top of the layer of Dawn dishwashing liquid because it is less dense compared to the dishwashing liquid. Oops, sorry, didn't mean to get to that on the sides. Okay. So we're going to watch that settle out while I clean my turkey baster. All right, boys and girls, the next thing I'm going to put in is an ounce. Remember, that's my volume. An ounce of just plain old water out of the kitchen sink. Remember, we're putting it in slowly and from the middle, just a little drizzle, a few little drizzly slow drops at a time. I'm not going to squeeze my turkey baster and make it come out too fast. So I should get a clear, see-through layer on top of my white almond milk. It's so hard to be patient and not force it in all at once. But I know if I do, I'm going to have to wait forever for my layers to settle out with their density. Woo! There it goes. Now, I've had my layer of honey, my layer of pancake syrup, my layer of Blue Dawn dishwashing liquid, my white layer of almond milk, my clear layer of water, and now, whoops, my husband says the other's better because it's got a darker color. He's going to let me use his nice, expensive olive oil. He's so nice. Oop, that won't fit in, so I need something to put it in, so hang on. Okay, boys and girls, now I have my olive oil, and it's got a funny little lid on it, so I'm going to have to pour it into my other cup so that I can get my turkey baster nozzle in. And I'm going to get an ounce of olive oil. Nice, rich, golden yellow olive oil. Any kind of cooking oil will do. It doesn't have to be the olive oil. It can be canola oil or vegetable oil or corn oil. Any kind of oil will do that you cook with. And again, I'm putting it from the center and I'm drizzling it in slowly, a little bit at a time. And we should see the oil float on top of the water because it is less dense. If it is more dense, it would be below the water. So we can see the olive oil now on top of the water. Okay, so my last layer that I'm going to put in is alcohol. This is plain old rubbing alcohol like you would use to sterilize your thermometer at home. And I'm going to mix in some red food dye because it will dissolve completely in the alcohol. Look at it starting to spread out. How cool is that? I can speed it up by just stirring. And then when it dissolves completely, I will not be able to tell where the alcohol stops and the food dye begins. Okay, so here I am with my solution of alcohol and red food coloring. Oh, I need to get an ounce. Whoops, make sure I've got an ounce. Have red hands tomorrow at school. There we go. And again, from the center and just drizzling it slowly on top. It's pretty thin liquid, so it wants to come out fast. So I'm trying to slow it down here. Keep it from going in with too much force, drizzling it from the center. Nice and slowly. And again, I'm doing this all on an old placemat. I don't care if it gets stained. Whoa, Miss McNally, slow it down. Ooh, I did it too fast. You can see it's getting a little bit of that red down in there. I'm hoping that it didn't go too far into my milk, because it might color my milk if it did. Oh, Miss McNally, keep it nice and slow and steady. It's important to follow directions exactly when you're doing a science, making a science model or doing an experiment. But I can still see my different layers. I may have just tinged some of them red by putting this in too rapidly. Okay, but still my different layers are clear to see. Remember, we had honey, golden yellow at the bottom, then the brown pancake syrup, then the blue dishwashing liquid, the white milk, the clear water, the yellow oil, and the red dyed alcohol floating on top of each other. So this is my liquid density tower. To make it more interesting, I'm going to predict about some solid items and where they would fall, how dense they are compared to the liquid. So I have an aluminum pull tab off of a can, a dime, a plastic Monopoly house, and a steel screw. So I think that my steel screw, for its size, has the most mass. So that must make it pretty dense. I predict it's going to go all the way down to the bottom. So I'm going to slide it kind of near the side and slowly let it go down. Oh, there it is down at the bottom. My hypothesis was correct. I just don't know about these other things. The dime? Maybe it'll go on top of the honey or the pancake syrup. It may go all the way to the bottom, though. It may have enough mass for its size. Let's find out. Let's drop it slowly in. Let's see where it lands. I'll try to put it on its side a little bit. Ooh, where is it, Mr. McNally? Can you tell? I'm having trouble finding it. It's hiding in there. Well, you know what? Did it go down to the bottom? No. Where is it? Do you see it? Woo. Well, maybe we need more light on the subject. We'll try that in a minute. Then I'm going to take my pull tab. I'm predicting that it will not go all the way to the bottom. I think it might float on the layer of Blue Dawn. Let's try it and see. There it goes. Can you see it falling? It did not fall all the way. See how it made a space there? There it is in the pancake syrup. And as it went down, look, it brought some of that Blue Dawn with it. So it's actually floating on top of the honey. How interesting. And last but not least, it doesn't have a lot of mass for its size, my little plastic house. I predict This will not go all the way down to the bottom. I think it's going to stop maybe about the layer of oil. Let's try it and see. Oh, it's very light. It's floating on the alcohol. It's floating on the top. So my little plastic house is even less dense. Mr. McNally, what?
I think it's actually, if you look from the side, it's resting on the oil.
Oh, so it's more dense than the alcohol and less dense than the oil. Yep, my head was looking from above, but now that I look at the side, oh, I can see it. There's my pull tab. It's sitting on top of the honey. There's my little house. It's sitting on top of the oil. He's right. I never did find my little dime. Where's my dime? But there's my screw down at the bottom. So I think that given that I can't see it at all, my dime is probably on top of the honey. Also stuck down on top of the honey and hiding in that brown pancake syrup. That would be my best guess. But look at my layers. You can see that yellow starting to settle out from the red food dye. But because I let my alcohol with the red food dye go in so fast, that red dye is wanting to color the other layers. So you're going to want to be careful not to let anything go in too fast if you do this at home. Cool. Science is fun. Thanks, boys and girls.